Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest is Arman Ghasaei. Arman, thank you for joining us. He is with iTune Power, and we're going to get into what iTune Power does. But first of all, who are you and why did you get involved with iTune Power? Give me your background.
Sure. First of all, it's a pleasure to be here.
Thank you.
I would say I started my PhD at University of Toronto in 2014.
U of T. I grew up in Toronto, my friend.
Yeah.
We're
Pleasure
simpatico.
again. Yeah, thank you. And that was the time that I realized I really have passion to contribute to power industry in general.
Okay.
And
Are you an engineer?
yeah.
Electrical?
Electrical engineering at St. George campus, if you heard about it. And it took me 6 years to finish the PhD. Lots of ups and downs to develop this proprietary technology that I'm going to talk about. Then my wife, she got admitted to UBC in family medicine residency in British Columbia.
Yeah, right.
And as you know, happy wife, happy life. So
You're a smart man.
Yeah, this is going to be like recorded, so my wife gonna watch this 10 times. And then we had to relocate from Toronto to Vancouver. And my passion for entrepreneurship led me to incorporate my own company, iTune Power. And it's a pleasure to be here.
Okay, excellent. So how long has iTune Power been in business?
Sure. I finished my PhD in December 2020.
Okay.
And then from March 2021, I incorporated the company. But that was the time where we were relocating from Toronto to Vancouver. So it was from August 2021 that we officially started commercialization.
Okay. What's your PhD in?
So electrical engineering is my major, but power system studies and testing is my specialty.
Ooh, okay. We're going to do other interviews together because I want your brain. Okay?
Oh, thank you.
In our APC Technologies, APC Media, we report on the power industry, but we'll do that. You're here at the RE Plus conference, a renewable energy conference. We seem to be at an inflection point, that's what we call it, that point where it seems to be taking off. Decarbonization is happening.
Correct.
The war in Ukraine has all of a sudden shocked everybody to say you can't be dependent on an unreliable source of energy.
Yeah.
And then the government finally here said, look, we're going to put billions of dollars into it. And that's true in the United States. I think it's also true in Canada and Europe, definitely. So you've got all of these factors which are converging to create the perfect storm, but it's a positive storm. You're a power guy. You understand electric power. Talk about what you see for the power industry with renewables and that very point that we're at where it's beginning to take shape.
I would start saying that it's promising to see that modernization is taking place. But at the same time, it's taking place on a legacy electrical energy system. And this big shift is not going to be seamless unless you are addressing the technical requirements that are needed to realize this decarbonization. I would say the gap that I'm seeing right now is that there are EPC companies for energy storage system. There are EPC companies for solar energies, wind power plants, but they do not operate in a consolidated manner. And the reason is that there are not clear management solutions that can provide coordination between renewable energies, energy storage systems, and that is leading to kind of a dysfunctional dynamics between utilities, between local distribution companies. Having said that, I can refer to a recent event that happened in Texas.
The big freeze or the latest one, the heat?
Let's start with the big freeze.
Okay, start there.
So it was in 2021. What I want to highlight was there was a fault happening at the ERCOT power system. And this is, by the way, is released by NERC as well. There was a unnecessary 1.2 gigawatt solar generation curtailment to clear the fault, which was unnecessary, but it was realized later on. And this year, 2 months ago, there was another event of the same nature where there was 2.2 gigawatt unnecessarily solar power curtailment to clear a utility fault.
Yeah.
So NERC kind of dig down into this issue, and they released they call an incident report, and they said the reason behind this unnecessary curtailment was lack of a proper control system developed. So we are getting to the point that there is a gap between EPC companies and technology and solution providers. So I know that President Biden is bringing IRA. So a major of IRA should focus on subsidizing or providing financial support for control solution providers. And if I really feel if that gap going to be filled up, we are going to see a better trend in terms of the 3Ds, which means decarbonization, digitalization, and decentralization of electrical energies.
The 3Ds, everybody's talking about it.
Yeah.
Okay, so with those problems, with that issue, iTune Power, how are you solving some of those?
Sure. We have a patent pending power management system. What it does, it is complementing commercially available energy management systems which are offered by Schneider Electric or GE. We started last August, as I mentioned before, but I am thankful that we have been able to secure 2 projects in Canada, one in Ontario and one in Quebec. For the project in Ontario, we are complementing Schneider Electric EMS by utilizing our in-millisecond AI-based power management system. So what our system does, it can proactively envision accidental events that can happen in power system. Like, let's say you have a squirrel which is choking a power distribution line. So not only that a squirrel will be incinerated, the connection from the utility can be lost.
Yeah.
So the existing commercially available EMS systems cannot maintain continuity of operation of the downstream power system which is disconnected from the utility. So our power management system can provide that fast coordination and that algorithm to keep stability of the power system or resiliency and enable enough time for re-execution of energy management system.
So who are your customers? Who do you go to market? Obviously, you're on top of a Schneider system or a GE system, but who are your customers? The utility?
Sure. I would say our immediate customer segments are utilities right now. For the project that we have in Ontario, we are working with IESO, which is the major utility in Ontario. But for the project that we are starting in Quebec, so it's a microgrid owner. There is a 230 kilowatt microgrid. But we are grabbing the attention of OEMs as well, Schneider Electric, Schweitzer, and Siemens. They are seeing
Okay, they're all going to try to buy you, you know that, right?
We hope that's going to happen, really. Yeah.
Okay, that's how you can scale. You get
Exactly.
But there's a point in that. If you could speak over all those systems and somebody buys you, now you're no longer interoperability. You're now siloed again. How do you do something that doesn't rely on any one of those vendors, if you will?
Sure, that's a great question. I have to say that the way we are commissioning our projects is using our second value proposition, which is our hardware in the loop testing capability. What we do over there, we simulate our customer's power system in real time. Real time means if you have a phenomenon, like opening of a circuit breaker that takes 3 milliseconds in the physical system, we simulate that phenomenon at 3.30 milliseconds. So it's a real-time simulation. And then we evaluate and verify performance of our power management system before field implementation. So So this gonna help us to reduce time and cost and risk with the EPC process of our projects. And as you said, there are regulatory issues which are involved with utilities. This hardware in the loop testing is gonna help to alleviate complexity of commissioning the technology on our customers' barrels.
So in short, your is it a power management system?
Yeah, PMS we call it.
PMS, right. And so in short, you have one that can overlay on anybody else's system.
Yeah.
Now. Okay.
Or retrofit, that's it, the term we use for that. Yeah, exactly. As I mentioned, we are complementing EMS system, so the functions that we are offering are not going to overlap with the EMS capability. And to maximize the efficiency of this retrofit process, we not only test our hardware implemented power management system, we also test other hardware control systems that are involved in the operation of the targeted power system. So let's say there is a customer who has a Schneider EcoStruxure EMS, we will test our PMS, which is running on our hardware platform, but we also test a Schneider EMS, which is running in parallel with our power management system. And also we test the local controller of battery or other renewable energy resources. So we can have multiple hardwares creating a loop with a real-time simulator to comprehensively doing those hardware in the loop testing.
It sounds brilliant. I hope you don't sell out to any of them and that you create an infrastructure over everything. So when you do your IPO, let me know.
Sure.
I'll make sure that we support it. You mentioned something, and I think it's when you do these projects, you're starting them now, right?
Yeah, we actually completed a project in Ontario.
Okay, is it Ontario Power?
IESO.
Oh, okay.
Electric System Operator in Ontario.
Is that can you do a case study on it?
Yeah, what we have done, we can provide a live demo of our hardware in the loop testing. Which is showing how our technology is going to work on their system. And of course, we are in the process of finalizing the field testing of the technology. And we are going to release a report which is going to include the case study of that project as well.
Because I would like to write about it as a case study. You don't have to mention the company, but mention the technology and what happened when you did it.
Sure, yeah definitely.
That would be real. So it's almost as if you're creating this digital twin of power management issues.
Oh yeah, that would be the right term. Yeah, digital twin for the EMS.
Yeah, that's brilliant. Because I've looked at the Siemens digital twin. They did one of, I think Siemens did one with Bentley Systems, and they did it for a large utility in the United States. It was brilliant. It was also very expensive. So the thing that kept it from happening on scale was cost. How about yours happening? Is it going to be you don't want to give it away, I know, but is it cost effective?
Yeah, it's a very controversial topic, cost in general. I would say let's talk about rate of return on the investment that our client going to make by purchasing our system. So generally our power management system right now costs less than $100,000 in general. But every power outage that our customer can save, we all know that the power outage legislations are exorbitant.
Right.
So every outage that they can save, we are talking about millions of dollars.
Right.
So the rate of return on the investment, of course I should not say that, maybe our customers should comment on it, but we see the math is quite easy.
Okay, all right.
Yeah.
So and that's what cost is not an impediment.
We believe so. It shouldn't. It hasn't been so far for our two projects, right?
Okay. Last questioning. What do you think the future is of renewables, and how does iTune Power, not iTunes? How do you fit into that future?
Sure. I will say the future architecture that we are going to see with modernized grid would be multiple microgrid systems.
Yeah. Oh yeah.
I believe this is going to happen. Not to advocate my PhD thesis, but
it was a thesis. It's a PhD that you advocate.
Yeah, I kind of did that. But the reason is eventually you cannot have the entire North America power system interconnected
Right.
and provide a single management system on top of it.
Right.
So you need to come up with distributed management system
Right.
for power systems. Distributed management system means distributed controllable entities of the power system. These controllable entities going to be microgrids, so we have multiple microgrid
Okay.
architecture, I believe.
And that bodes well for you because your power management can play over all of them.
Yeah, in a hierarchical manner,
Yeah.
we can provide that management system
Okay.
to provide like interaction between the microgrid, while each microgrid keeps its own ownership. But we want to make sure that the integrity of operation through the shift from a centralized architecture to a multiple microgrid architecture going to be preserved.
So this is the first RE Plus or any type of event, given how new the company is. You're relatively new. This is the first one you've been to?
No, I was in San Antonio 4 months ago in Clean Power
Clean Power.
exhibition
Okay.
as
Yeah.
well. That was also good, but I like RE Plus more
Okay.
because of this interview.
Okay, good.
No,
I like this interview because of RE Plus. That's good.
Yeah, that's
So far, acceptance, have you been getting good traffic, good acceptance?
Oh yeah, what I really liked about RE Plus was designation of different ventures and companies based on their technology. So
Okay.
we are located in microgrid space.
Okay.
And of course, our power management system gonna operate well for microgrid system. So the traffic that is coming by our booth, they are looking for cutting edge grid technologies, grid edge technologies. And I really like these, I would say, allocation of companies based on their offerings and technologies.
Yeah. And one of the things that's happening from the big generation push down, step down business, the whole microgrid world is changing because industrials are now looking at, they can't rely on quality power from the fact that DER creates all kinds of transients, they affect power quality and things. So there are a lot of people now talking about microgrids. I've heard it more at this conference and at the IEEE PES conference, which is a T&D conference.
Yeah, the transmission and distribution.
The T&D. Even at that one, I heard more talk about microgrids, which I think is the future. But anyway.
Yeah, and I think multiple microgrid is the future.
So multiple microgrids.
We are on the same page, I believe.
Yes, we are. Anyway, thank you so much.
It was a pleasure. Thank you so much.
We appreciate it.
Yeah.
Good luck.
Thank you so much.
So all of these interviews that we have conducted have been sponsored by the people behind me. The first one is the Grid Edge Conference and Exposition, which takes place in April 2023 in San Diego. The IEEE PES Grid Edge Conference and Exposition has been a long time in the making. This will be our first one, and it will be a delight. I can already tell you that we've had more papers, more panelists than we could possibly hold, and the conference itself is going to be brilliant. The second organization sponsoring us is H2Scan. H2Scan is ubiquitous in the transformer industry as the best. It's kind of like Intel, it's inside. H2Scan is a hydrogen sensing technology that is patented, that has been around for the last 20 years. It really came on strong as transformer hydrogen became a problem. DGA recognized by IEEE. And I just thank the people at H2Scan. They are also in electrolyzers, fuel cells, battery storage, but hydrogen safety is incredibly important. They're in refining, in processing, so H2Scan, thank you. Lastly, RE Plus. We are at the Renewable Energy Plus Conference and Exposition, and as we close this one out, I want to thank them for allowing us to conduct these interviews here, for allowing us to be part of their incredible conference. It's been enormous. There have been 27,000 people that have attended this conference, and you can tell the energy, the excitement that's taking place within the renewables industry, so thank you, RE Plus. It's been a delight to do these interviews, and I hope you've enjoyed them.